And we're coming back to another exciting edition of Mr. Hole's Virtual Classroom. In this episode, we will be learning about how to solve equations of inequalities. By doing so, we are going to have to add and move around inequalities without using equal signs. So with that being said, it's time for class to get started. I'll be your friendly host through this, and if you would, join me on page 331. Alright, so on page 331, we're going to be looking at solving these inequalities. If you look up above example 1, you guys are going to see what's called the properties of equalities. And one thing you'll notice about those is you have actually done these in some fashion earlier on in the year when you were learning about associative property, commutative property. Those were just things that you were applying, but they were with equal signs. You know, if A equals B, then B equals C. So A plus B equals C, therefore B plus C has to equal A. That's what you're saying here. Although you don't have equal signs, you have inequality signs. And inequality signs are speaking of less than, greater than, less than or equal to, or greater than or equal to. So let's take a look at example 1, if you would. It tells us that we're going to solve negative 4x plus 3 is greater than 23. Well, tell me this, so the only thing that is a little different is instead of having an equal sign here, you have an inequality sign, right? So we still do the same concept, move this to the other side. Negative 4x is greater than 20, right? Because that was negative 3 when we moved it over. Divide by 4, divide by 4. That gives us 1x is greater than. I mean, it's actually less. It says less than the way the sign is now. So less than. And what's that going to be? Negative 5. But that can't be right because obviously if we get 1, we can't say that 1 is actually less than 5, right? So since we divided and made this positive right here, we actually need to change the sign to say 1x is greater than negative 5. Because we changed this sign here and made it a positive. Okay? Now, had it still been negative, you would have kept and subtracted both sides. So you're taking what's called the reverse. And we did by taking and dividing negative 4 by negative 4 and getting a positive 1x. So it flips our sign. Since this is negative, we want to... If it had been negative, negative, the sign would have stayed the same. But since it was a negative and a positive, we flipped it. Alright, you'll see a little bit more of that on as we further on. I do want to talk to you guys about putting it on a, if it asks you to put it on a number line. So these symbols right here represent open circles. Okay? If you have, these represent closed circles, and sorry it's taken like 5 million years to come up there. So since ours said that it was open, that means we go to negative 5, an open circle, and it goes on to infinity as such. Alright, so if you would, flip on over to the next page, and we'll look on page 332, and we'll get on example 2. This is a relatively short lesson, so I'm going to do my best not to make it too overwhelming. But, I mean, sometimes it's just math, you know what I'm saying? We have the dreadful fractions.
What?
I know. Fractions. They're terrible. I hate them. And I know you guys do too. But we got to bring this little guy into this problem. So it says we got a negative 3/4 x plus 8 is less than or equal to 23. Okay, so what's the first order of operation we want to do? Bring the 8 to the other side, Mr. Hall. Well, thanks, Timmy. Yeah, we're going to bring the old 8 over. And what does that give us? 15? Good. So we got 3/4 x is less than or equal to 15. How in the world do I get rid of my fraction? Well, I'm going to take 4 on both sides. The book will do it a little bit different. I think this is a lot more simplistic, so if you can follow along, try to grasp what's going on here. That way I can divide by 4, and I multiply this one by 4, and that gives me 60. So I'm now left with negative 3x is less than or equal to 60. I can divide by negative 3, divide by negative 3. 1x is now less than or equal to what? 15. And when I mean, I didn't mean 15. Why did I say 15 when I meant 20? And that's going to be a negative because I divided by negative. So, since the inequality changed, that means my sign now has to flip the other way because my inequality, and that goes back to what we talked about, the reverse sign. So we're taking 1x, and now becomes greater than or equal to negative 20. Okay? So again, just a quick recap. We moved this over to the other side because that's what Timmy told us to do. They gave us 15. I needed to get rid of my fraction, so this is really, if you want to think about 4/1, so that way you understand why you're doing that. And then if you cross multiply here, that's still negative 3. Then you multiply the 4 over here, and that gave us 60. Our new equation was negative 3x is less than 60. We divided by 3, okay? As you can see, divided by 3. That gave us 1x is less than or equal to 20. We did the reverse because the sign changed. Okay, so now it's 1x is greater than or equal to negative 20. Now, if you were asked to write that on a number line, well, we need to go to the number 20, negative. Our sign was what? What kind of circle is it going to be? It's going to be closed because it's greater than or equal to. And that's how it looks on a number line. Okay. Let's move on to example 3. It says we have negative 2r plus 4 greater than 19. So my question is, what's our first step we're going to do here? Nothing has changed minus the inequality sign. We're still going to do distribution. So if I rewrite that, that gives me, let's do here first, negative 2r plus 2 times 4, that's negative 8 and 19. Well, guess what? The hard part's already behind us, isn't it? We move this to the other side. What does that give us? That's positive. Mind you, that's a positive. So that gives us negative 2r so far. It's greater than 27. Now I need to divide by negative 2 and negative 2. And what do I get? I get 1r. What do we get? 1r. Yeah. And since the sign changed, okay, the sign changed right here. It becomes negative to a positive. That means this has to flip, okay? So now our sign points to the left, and our answer is negative 13.5. That's what I got when I divided negative 2 into 27. So that's what we're talking about, a reverse inequality. The sign flips because if they're positive, if they were like positive 2 into a 27, the sign would have stayed the same. But since we did a negative to make a positive, the inequality flipped. Because what you're saying is you're changing your entire number. It went from being a negative to a positive. So this can't stay the same. It has to flip. Alright, let's look at example 4. Example 4 says solve 2x what do we have here? We have double. Somebody? Timmy, you just answered the last one. I know, Mr. Holman, I want to answer this one too. We have double variables. Well, Timmy, can you sing us the song that we sing about how we need to solve for this? Sure thing, Mr. Holman. It goes like this. Variables on the left, constants on the right. Variables on the left, constants on the right. Timmy, that was just amazing. Your singing just really touched my heart and moved me there. So he was right. We had variables on the left and constants on the right. So I need to move this over according to Timmy. And what does that give me? That gives me positive 4x. So my question now is, you're dividing, this is the first time you got to divide positive into a positive. Does the sign change? So 4 and 4. So 1x is what? But at the same time, I was like, I mean, that does make sense because we can't all three fit on the couch, you know, like. Oh, and I want to apologize to my wife. She kind of loud. So this is the first time we and I don't know why they did. There's a misprint in your book, so don't mind that. So 1x is greater than 2. Yeah, your book says 4, so don't pay attention to that. So that's perfectly fine. And I want to thank Timmy for participating in that one. He really helped us through there. So let's go ahead and move on to the next example. Man, we're just flying through this. You guys are killing it. All right, so we have 3x minus 1, x plus 9. Well, we got double variables and double constants this time. So we want to go ahead and move this over, and that gives us 10 for the, and we'll go ahead and put our inequality sign. And if I move this over, it gives us 2. So we have 2x equals, is less than, I'm sorry, not equals, less than 10. So 2, 2, and since we're dividing by what? We're dividing by 2 constant, like 2 even numbers, so it's going to be 1x. Sign doesn't change because they're both equal. So 1x is less than 5. And if you were to put that on your table, you go to 5. 5, open circle. Dun, 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 dun. And, friends, we come to our last example, if you will. This says we have 5x minus 8 is less than or equal to 9x plus 2. Let's go ahead and move this guy over. That gives us a negative 4x less than or equal to. If we move this over, that gives us a positive 10. We divide by negative 4 and negative 4. That gives us a 1x. The sign changed because it went from positive or negative. That means this is a reverse inequality. We now flip the sign, and it's 2.5. So 2.5 is now our answer. So my question is, how do we write this on our number line? So just a quick had these been both, if this had been positive and positive, the 4s that is, you would have kept the sign the same. But since it's a reverse, because you went from making a negative positive, you had to change the sign. So let's go ahead and write down on our number line. We have, is it open or closed? It is a closed circle because it has the equal sign underneath.
That was easy.
Well, I'm glad you seem to think so. Well, with that being said, you guys did amazing. I sent you guys all your information. You guys should have your Facebook page. You can see any questions you have. Please call me, and we will make sure. Call me, text me. You can do video conference, and we will make sure that you guys are grasping the knowledge that is going to take to complete these assignments. With that being said, super proud of you guys. And it looks like it is about time to say goodbye. I've been your friendly host for this episode of Inequalities. Thank you for joining me in Mr. Holt's virtual classroom. And until next time, I'll see you guys later.